Yeah. So today, let us start the second session, which specifically is on something which is called as Deepstream. And this basically will be related to the previous session, which was related to intelligent video analytics. So let us try to see the agenda for the day. We'll cover what Deepstream is, what's a Deepstream graph architecture, how will you use a Deepstream SDK, and since you are using Python, how is that the Deepstream Python binding is generically used? And we will have about 3 to 4 demos today. So 2 demos we will be showing you on Dockers, which basically will use Deepstream and run on a laptop come DGX type of a system or anything. And then 2 demos which will show specifically on the inferencing portion, which runs on the edge device like a Jetson TX2 or Jetson Nano or whatever, right? So this is the overall agenda. Now, if you recall, we actually in the previous session started with what a computer vision is, what are computer vision systems, and we showed you some examples of video analytics, and we also understood the difference between what a object detection does as against what a object tracking is. And we showed you the sample for a parking thing, and today most probably we'll show you the parking thing also, uh, which basically would involve GPUs and which will be more real time, right, in processing as compared to the previous example which we showed in the previous session. So now we all know the difference between the central processing versus the edge processing. And if we are trying to do it on the edge device itself, okay, so for example, when you talk of video analysis software, it can be run centrally on the server that are located actually in the monitoring stations or at data centers, and this is called as central processing. Or that particular software could be embedded in the camera itself, right? And then camera would be there on the edge device, and you can call it as edge processing, right? So this is the basic distinction between when you try to develop a central processing type of application versus a edge processing type of application. Now let us try to go into a bit of a detail on what a deep stream is. And if you see deep stream is an open source toolkit which NVIDIA has designed, and which is a streaming analytical toolkit to build AI powered application, right? And what does it simplify actually? So NVIDIA Deepstream simplifies the whole development process for developing a scalable intelligent video application. So any intelligent video analytics application, okay, development is simplified when you start using Deepstream. And why do developers actually need to use Deepstream type of applications, right? So you can basically do this to quickly build new applications, okay, and transform your video, which will give you some good insights very fast, right? Because that particular pipeline develop is such a nice type of pipeline, right? When we discuss this, it's very scalable and it's very easy for application development to happen, right? And the SDK which is now there, okay, you can develop applications which will basically involve image classification, scene understanding, you talk of video categorization, content filtering, so many of them, right? And this Deepstream SDK is based on the GS or GStreamer framework, right? So if you go to this is a very important, okay, flexible, fast, multi-platform multimedia framework which is called as GStreamer, okay, and this is a versatile framework for creating streaming media applications, okay, And one of the things which, if people would have been working on multimedia application development, they would understand that one of the important things of this G streamer is that it is very, very modular, right? And you can plug in new modules as and when required. And this modularity is a very, very powerful thing about this G streamer, which will help you to actually develop applications which can be very easily deployed, right? So this is what is our interest. And this particular Deepstream SDK, okay, is basically developed using this G streamer framework, right? And if you see also that there is something which is called as NVIDIA Metropolis, and this Metropolis is a platform which gives you end-to-end services and solutions for transforming pixel and sensor data to actionable insights, right? We are not going into Metropolis for the time being, but Deepstream is a central portion for NVIDIA Metropolis, which is very, very good for developing applications which are related to smart city, right? So this is how the whole Deepstream overall, right, um, looks like, right? Now, there is a specific pipeline which we call it as a deep stream graph architecture. Okay, if you understand this at a level wherein what does this architecture or framework help you to do? So it helps you to do end-to-end development, okay, of any streaming application which you are trying to develop. So it starts with something called as capture, and it ends with something wherein you will get some output, right? So this is the total framework from starting to the end, and these are the various hardwares on which each of these stages could be run. So let us go into a brief of one-liners of what all of these modules do during your whole pipeline, right? So capture, the first step is to capture your data from multiple cameras. It can be through real-time streaming protocols, or it can be a raw data or whatever. This particular module captures the information. It can be done on a CPU. Now then there is something which you need to decode, right? There is some portion which you need to decode. So decoding is done using NVDEC, and this basically is a module which does some decoding. There are details available. We'll share the link with you if you want to go into the details of each modules, but for the time being, in interest of time, we're just telling you certain things which will help you to understand and appreciate the context under which we are trying to develop in some applications, right? So now this image processing portion, wherein you can do scaling, you can do dewarping, and you can do cropping, okay, of some portions of your image or the frames or whatever you call, can be done on GPUs or ISPs or some VICs, okay. Now this is video intelligent codecs, ISPs and GPUs, right? And then you can do some stream management batching type of applications. This module is done on a CPU. Then this is deep learning accelerator. This is a GPU which will help you to run DNNs. It will help you to detect, classify and segment anything. Then you can do tracking can be done on a GPU or a CPU. Then again visualization, it can be an on-screen display. Again you can do GPU, you can use it for rendering, you can use your VICs for it, and ultimately in the end you can either do a display, or you can store it, or you can basically put it into cloud. And this particular output, right, can be viewed using a HDMI or SATA type of a stuff or whatever. So the basic idea is this whole of this particular architecture, okay, would be useful when you basically would like to develop such an application. So yeah, so if you want to actually develop a Deepstream app, Deepstream reference application, so the reference application, as I told you, is the GStreamer application. You would be using the GStreamer framework as I showed you. Excuse me. So this GStreamer based solution will consist of set of Deepstreamer plugins which are basically considered to be low level APIs and which will give you a complete graph or a complete end-to-end pipeline, right? So this app is fully configurable and you can actually hold a pre-built inference plugin also. So as it is very modular in nature, you can go on adding various plugins, okay? And the capabilities of this Deepstream, okay, uh, would be basically very useful when you try to develop in some applications, as we will see in some of the examples. Now here, the first thing is to capture. So you will have number of input sources, types of sources, resolution. It can be video, it can be real live input from the camera. Then you do the decoding, there will be batching, then you have this object detection, then you can track, then there's a classifier which will help you to basically do many things, and then you can do tiling and on-screen display visualization, and then it can be either done on the edge, we will show you this, as well as on premise through the cloud or on the data center or whatever. We'll show you both some examples of this, and then this is what basically a Deepstream application is going to help you to attain. Okay, so now that whole application which we talked about, which are the various steps, okay, they may appear, this may appear, the slides may appear to be repetitive, but it is going to give you a fair understanding of how basically or what uh, total thing is involved when you want to develop an application using Deepstream, right? So as I told you, right, this is GStream's URI code, GStream's URI code. So this basically is a video decode step after you get the whole input from the camera, either it's live or using RAW or RTSP or whatever. Then there is a mux. So this uses something called as NVStream mux. It is GST NVStream mux. So the GST or the GStreamers framework, then they have added, the NVIDIA has added NVStream mux for it, and it becomes a stream mux. And then there is a primary detector, which is basically a plugin, which is basically a inferencing module, which involves something like TensorRT thing, and then this is a tracker, and then there are secondary classifiers, like for example the make of the car or the model of the car or color of the car, and then there's a tiler which basically gives you as to how do you get the output displayed, and then this is something like on-screen display, then this is something which is called as a renderer, right? So if you see that way, the steps are almost the same, but we are trying to link each of these steps with certain modules which are actually implemented using the GStream framework, which is effectively uh, implemented or developed using plugins which NVIDIA has given us as Deepstream, and which efficiently runs on inferencing as well as on the GPUs, right? So this is the overall application architecture. So to go into the details of what each of these plugins provide to us, these plugins actually are implemented by NVIDIA, and they are a part of Deepstream SDK. Now, for example, This stream muxer plugin, which is called as GST NVStream Mux, actually forms a batch of buffers from multiple input sources. So what does this plugin do effectively? You are going to get a lot of buffers, okay, based on how many multiple input sources you get, okay, and for each of these input source, this GST NVStream Mux is going to create a buffer for you, right? And then the pre-process plugin or GST NVDS pre-process is for pre-processing on the predefined region of interest for primary inferencing. So the idea is you will have a preprocessor plugin which will help you to pre-process the data based on the region of interest. As in the previous example, previous session, we saw that we wanted to actually have the image of the center of the screen, right? So we cropped it from the center. So that was our region of interest. So region of interest can change, right? So the region of interest has to be selected. So we can use this preprocess plugin for the same. Then there is something which is called as GST NVInfer, which I told that it is related to TensorRT. So this is a NVIDIA TensorRT based plugin which will help you to do some primary detection and classification, right? So you can actually use this plugin for detecting and doing some classification. Now, then there is something which is called as Gstream NV Tracker. So it's a plugin again, which will help you to work with OpenCV, okay, and which helps you to do object tracking with a unique ID. So you are using OpenCV for tracking, and then you are generating a unique ID. Then this is this multi-stream Tyler plugin, which basically does or gives you a 2D array of frames, right? So this is a Tyler plugin, and you can get multiple stream tilers. So you get these tiles, right? And then you will get a 2D array of frames as each of these tiles, right? And then this on-screen display plugin basically is GST NVDS OSD, is to draw shaded boxes, rectangles, and text on the composite frame using the generated metadata. So this basically means that your on-screen display is going to actually draw certain boxes, rectangles, and you can display text also on this composited frame, right? Which basically will help you to generate certain metadata if required or something of that sort. Now this message converter and message broker is a plugin which will help you to actually send in analytics data to a server in the cloud, or this is a broker type of a communication which you do. Okay, so message broker type of communication, and then there's a converter obviously needed. Okay, so if you see what actually a Deepstream SDK gives you, so it helps us to actually do a complete streaming of some AI based videos along with some analytics, right? So it is actually helping you to do streaming analytics for AI based sensor processing, right? It can be data from the video sensor, audio sensor, or image understanding, whatever, right? It's very powerful and flexible. It uses low code programming in the sense you have this graph composer, okay, which is very simple and intuitive UI. We are not going to actually go into the details of graph composer today, but we'll surely give you links. You can just see them, but we are going into a bit of technical demos today which will basically help you to appreciate the power of Deepstream SDK for inferencing as well as no on any of these GPUs, right? So it gives you real-time insights, multimodal sensor data, and you can develop managed AI services. You can deploy AI services on the cloud using containers, and you can orchestrate using Kubernetes. Okay, and then you can train with the Tau toolkit, which uses Deepstream to increase stream density, right? So this is the overall idea of why you should be going in for Deepstream applications if you are doing video analytics. There is no other better framework, okay, if you are working on video analytics or video processing for that matter. Okay, so this is how basically it's going to pan out. Your total Deepstream SDK will have turnkey apps you can develop in your application. You will have container builder, and then this container builder basically you can use, right, with a graph composer, or you can develop your applications using C++ or Python. Okay, so that the whole container could be developed, and then you can actually link that container of yours for developing certain accelerated plugins and extensions. You can use that with it. You can use that container with a pre-trained model. You can use that with one-time model update. You can use it for IoT messaging. You can use Helm charts, and then all of this can run, okay, on CUDA or TensorRT or Triton or multimedia and RiverMax IO. So this is related to IO, and then all of this could be either run on EGX servers, Jetson for inferencing, or on cloud. So this is how the whole Deepstream SDK looks like. Okay, so for example, some of the applications wherein Deepstream SDKs would be used or are being used, okay, is like access control, smart parking. We showed you example of smart parking the other day. Today also we'll show you something of smart parking. Okay, and then these are used for retail analytics and checkout. You can use it for intelligent traffic systems. You can use it for law enforcement. So modular scalable architecture we are talking of. We are talking of application integration. You can work with various DNNs. You can work with various developmental tools, right? And then you can work with multimedia, imaging, as well as deep learning. So you can work with TensorRT, cuDNN. You have facilities to work on Linux, CUDA, and then each of this can run on any of these NVIDIA platforms, right? So this is how it's going to happen. So why you should use Deepstream SDK, I have told you various reasons of trying to use it. So these slides will be shared. You can have a look at these as well. So one of the things is it is a powerful end-to-end AI solution development toolkit. That's very, very important, right? So this is how you are going to build your application. As I told you, you are using GStreamer, and then you have these plugins, then these low-level APIs, and then these low-level APIs basically run on these hardwares, right? This is another way of representing whatever we had discussed previously. Okay, so when you start developing Deepstream applications with Python, you should understand that you are trying to use certain pi bindings here. Okay, so there is something which is called as GStream Python, and then based on these Python packages, right, you have Deepstream Python app. So you can do this, and then you can do certain bindings and wrappers, and then you can use it. You can use C++ as well as Python both for it. And if you see the platform and the OS compatibility, right, there are so many Jetson platforms. We are not going into the details of it, but these are various platforms on which inferencing can be done, and majority of this OSs which you work with would be Ubuntu. Okay, and then you have to use Jetpacks. You will use Linux for Tegra because we are trying to use these inferencing devices which are Jetson uh, kits, right? So that's why, and you will work with CUDA. So this is one thing which you should understand as to how is the compatibility of which OS with which Jetson model and which Deepstream release, right? So the same thing holds good for various GPU platforms. So this was just Jetson platform, this was GPU platforms. So we'll show you both the examples today. And then when you're trying to work with something like discrete GPUs, okay, so there are Docker containers available. We'll try to work with Dockers as well. We will be using with Dockers only. So now these Docker containers, there will be base container, there will be development, there will be Triton, there will be IoT, and there will be samples, right? So each of these containers, okay, will have some specific things, right? For example, um, base Docker could be used to build custom Dockers for Deepstream applications. Development Docker will give you the graph composer. Triton inference server Docker, you will get an inference server and certain dependencies which are installed for building deep streaming applications. Deepstream IoT Docker will give you certain specific facilities wherein your Deepstream program could be basically linked to some IoT based application. And then there are sample Dockers which will give you, right, runtime libraries, samples, and various other things. So this is for discrete GPUs, right? Discrete GPUs, uh, okay, are GPUs which are specifically not integrated as a part of a processor. These are separate GPUs, right? So yeah. So then there are Docker containers which are available for Jetson devices also. So the idea is these are for discrete GPUs, these are for Jetson devices. So you understand the now difference between these two now. So these Jetson devices require Dockers which are less in size, right? Which are small in size as compared to Docker containers which require to be run for discrete GPUs. You again have a base Docker, you have a IoT Docker, you have a Triton Docker, and a sample Docker here as well. Okay, so there is one thing which I would like to specifically talk about is these configuration groups. Okay, now each of these applications when you develop, you have got various plugins, right? And these plugins are readily available to you. The only thing which you need to understand is each of these plugins can be configured based on our needs. Okay, and then these configuration things are to be maintained as config.txt files, and these files need to be used by the Deepstream SDK for taking appropriate inputs for various plugins, right? So there is this document which talks of this reference application, and this is how basically you can actually predefine a ROI, okay, a pre-process plugin getting enabled, and something like preprocessor plugin getting disabled. Okay, so many examples are there, and these are the various groups, right? Pre-processing groups, stream mux group. So you know that there is a stream mux available. Now this stream mux group will specify the properties and behavior of the stream mux component. So if you click on this, it will tell you as to what particular type of properties and behaviors, right, you need to actually give the inputs to. So in this, when you are talking of this NV Stream Mux plugin, you will have all of these values, right? You have GPU ID, what is the key, right? Live source, what is the buffer pool size, what is the batch size, what is the width, height, right? What are the various platforms you can use, and how do you give these parameters into the plugin as inputs. Okay, so all of this. So what we are going to do is we can show you some demos now, and in those demos we will try to show you the config file as well. Okay, so we'll try to show you the config file as well, and we'll start the demos now. So the first thing is, let me start it on this particular, 1 minute. Let me start this on 1 minute. Yes.